I am Tahir, Department of Computer Science, Allama Iqbal, Open University. Today we will discuss database planning and design, which is part of unit number 3 of our course Database System. This unit covers the database development lifecycle, requirements collection, database design, DBMS selection, prototyping, and testing. Database planning is the process of determining how a database will be created, structured, and maintained so that it meets the organization's information needs efficiently and effectively. It is not just a formality, rather it lays the foundation for the entire system. That's why it is considered the first and one of the most critical phases in the database development lifecycle. Without proper planning at this stage, later steps such as design, implementation, and testing may face serious challenges. Now, let's look at the database development lifecycle. It is a structured process that guides us from identifying requirements all the way to maintaining the database system. The cycle has several key phases, which are requirements gathering and analysis, conceptual design, then the logical design, after that the definition of schema, then application development, and at last there are deployment and its maintenance. We will discuss these one by one. Now let's describe the system definition. System is the stage where we describe the major views, the application areas, and the general environment including both hardware and software. This step is important because it helps us clearly define the scope and boundaries of the database system. In other words, it tells us what the database will cover and what it will not. Without this clarity, the project may face confusion or scope creep later on. The next stage is requirements gathering and analysis. In this step, we collect information about what the user needs from the database. This is done through different methods such as interviews with stakeholders. Stakeholders are those people which are involved with databases. These can be users, these can be developers, these can be a customer. Then the questionnaire from all these are reviewing existing documents or reports. The outcome of this stage is a detailed specification of data requirements. This document becomes the foundation for designing the databases because it ensures that the system will meet the actual needs of its users. Now let's go deeper into requirements collection and analysis. This process has 4 main steps. First one is to identify stakeholders. The first step is to figure out who are the stakeholders. Stakeholders include anyone who will use or be affected by the database system, such as managers, employees, or even external clients that can be users of these systems. Then requirement illustration. Once stakeholders are identified, we gather their requirements. This can be done through interviews, surveys, observation, or studying existing literature. The goal here is to capture what they really need from the system. Requirements analysis. After collecting requirements, we carefully analyze them to remove conflicts, redundancies, or ambiguities. This step ensures that the requirements are clear, complete, and feasible to implement. The fourth point is requirements validation. Finally, we confirm the requirements with the stakeholders. This step ensures that what we have documented truly reflects their needs and expectations. By following these steps, we can be confident that the database system will be designed based on accurate and well understood requirements. The next stage is feasibility study and planning. In this step, we evaluate whether the proposed database project is practical and worth pursuing. This involves looking at 4 major factors: the cost, can the organization bear this cost, the benefits, then the cost benefit analysis, then the time it consumes to develop this, and finally the technical feasibility. Is this feasible technically? Are the organization having resources to develop these with respect to manpower and with respect to tools? For example, do we have enough budget? Will the benefits outweigh the cost? Can it be completed within the required time frame? And do we have the right technology and expertise to make it work? Once feasibility is confirmed, we move into planning. This includes defining the development stages, preparing a schedule, and allocating resources such as staff, hardware, software, etc. In short, this step ensures that the database project is not only useful but also achievable within the given constraints. Let's go through the process of feasibility study and planning. This step ensures that before the start building the databases, we know whether the project is practical and how it should move forward. The process can be broken into 4 main steps. These steps are: conducting feasibility study, where we evaluate whether the project is possible in terms of cost, benefits, technical resources, and time. If the project is not feasible, it should not proceed further. Then the risk assessment. We identify potential risks. These may include financial risk, time delays, technology limitations, or even resistance from users. Assessing risk early helps us plan for solutions in advance. Then analysis of alternatives. After identifying risk, we analyze possible alternatives. For example, if one technology is too expensive, we look at cheaper options. For example, Oracle is expensive, we can move towards open source or cheaper solutions. Or if one timeline is unrealistic, we consider phases development. The aim is to select the best possible approach. Then the developing plan. Finally, we create a development plan. This includes scheduling the project stages, allocating resources, and defining responsibilities. This plan becomes the roadmap for the database project. So overall, feasibility study and planning ensures that the project is achievable, cost effective, and well structured before actual development begins. The next step in database planning is logical and physical design planning. First, we have the logical design planning. In this stage, we focus on planning the logical schema of the database. This includes identifying the entities, defining the relationship between them, and applying constraints to ensure accuracy and consistency. The goal here is to design a model that clearly represents the data requirements of the organization independent of how it will be stored. Next, we move to physical design planning. Here the concern is how the database will be stored and accessed efficiently on the hardware. This includes decisions about indexes, access path, file organization, and storage structures. A good physical design ensures fast retrieval, optimized performance, and efficient use of resources. So in short, logical design is about what the database should represent, while physical design is about how the database will run on the system. How can we use it efficiently? The next important step is security and authorization planning. In this stage, we identify the different types of users who will access the database, the roles they will have, and the level of access rights each role requires. For example, an administrator may have full rights, while a regular user may only be allowed to view or update specific records. Next thing is roles and rights. We also plan for data privacy and security policies. This includes setting rules for protecting sensitive information, preventing unauthorized access, and ensuring compliance with organizational or legal standards. We apply this for making database safe, reliable, and trustworthy. Now let's talk about some of the major functions of database management system. DBMS is a software which we can use for creation and management of databases. So data storage, retrieval, and update is the first function of DBMS, and that is the most basic function of a DBMS. It's used for storing data safely and allow easy retrieval and updating. A DBMS ensures that only authorized users can access the system. Authentication confirms the identity of the user, while authorization controls what action that user is allowed to perform. For example, a teacher may update grades, but a student may only view them. Then data integrity management. The DBMS enforces rules and constraints to maintain accuracy and consistency of the data. For example, preventing duplicate roll numbers or ensuring that salaries can't be negative. Then transaction management. A DBMS supports transactions. Transactions are basically the steps we follow for performing a specific task. Its meaning a group of operations that must either all succeed or all fail. For instance, when transferring money between two bank accounts, both the debit and the credit must happen together or not at all. The next phase is concurrency control. Finally, concurrency control ensures that multiple users can work with the database at the same time without conflicts. For example, two students registering for courses simultaneously should not cause errors or data corruption. In short, a database management system provides not just storage but also provides security, accuracy, reliability, and multi-user support for managing organizational data. The next function is backup and recovery. The DBMS provides automatic backup and recovery mechanism. This ensures that in case of a system crash, power failure, or data corruption, the data can be restored to a consistent state without major losses. Next function is data dictionary management. A DBMS maintains a data dictionary that a central repository of metadata. This includes information about tables, attributes, constraints, indexes, and relationships. It acts like a catalog that helps the DBMS and users understand the structure of the database. The next function is database communication interfaces. The database management system provides interfaces that allow communication with other applications, programming languages, or even other databases. For example, APIs, ODBC, or JDBC connections are used to integrate the database with software applications. APIs are basically application programming interface. ODBC and JDBC are two connectors for Oracle-based database connectivity or Java-based database connectivities. Then the next function is data security management. Data security and database security are two different concepts. Earlier we discussed database security, now the data security. Beyond access control, database management system enforces detailed data security management. This includes data encryption, secure authentication, access logs, and auditing features to protect sensitive data from unauthorized use. The next function is data abstraction and independence. That's the final function. A DBMS provides data abstraction by hiding the physical details of data storage from the users. Users work at a higher level with tables, views, and queries without worrying about how the data is stored. This also ensures data independence, meaning changes at the physical level like changing storage devices don't affect the logical structure or user applications. So overall, these functions make the database management system not just a storage system but a complete, secure and intelligent data management solution. We discussed all these functions in previous slides. Now let's look at the main steps involved in selecting a database management system. There are number of database management system softwares. So we follow these steps for selecting these DBMSs. First one is to defining terms of reference of study. The first step is to clearly define these. This means outlining the objectives, scope and requirements of the DBMS we are looking for. For example, now many users will it support, what type of data will it handle and what features are essential. Then shortlisting 2 or 3 products. Once the requirements are clear, we identify 2 or 3 database management system products that best match those needs. This shortlisting narrows down the options and make evaluation more focused. Then evaluating these products. Each shortlisted product is evaluated in detail. This may include testing performance, checking compatibility with the existing system, considering licenses cost, support, scalability and vendor reputation. Then recommend selection and produce report. Finally, based on the evaluation, a recommendation is made for the most suitable database management system. A report is then prepared to justify the choice, highlighting the strengths of the selected database management system and why it best fits the organization requirements. In short, database management system selection is a systematic process that ensures the chosen system meets organizational needs in terms of performance, cost and long-term usability. Now let's discuss data model structure and constraints. Data model uses constructs to define how the database is structured. These constructs describe both the individual elements and the groups of elements. For example, an element could be a single attribute such as student name, age, grade, and it will have a specific data type like text, integer. Groups of element includes higher level structures such as an entity, a record, or a table. Data models also define the relationship among them. These relationships are one-to-one, one-to-many, many-to-many. In addition to structure, data models also include constraints. Constraints are basically rules that restrict the kind of data that can be stored to ensure accuracy and consistency. For example, a constraint may specify that a student's age can't be negative or can't be in textual form, or that roll numbers must be unique. These are constraints. So constraints define the structure of the database, while constraint ensures the validity of the data stored within that structure. The next step is prototyping. Prototyping means building a working model of a database application before the final version is developed. The idea is to give both developers and users an early version of the system so that they can test how it works, provide feedback, and make improvements before committing to full development. There are two types of prototyping. One is throwaway prototype and second one is build upon prototype. In throwaway prototype, we just develop a prototype and for agreeing the stakeholders, and in the second phase, the build upon prototype, we develop this prototype towards a working system with the feedback of user. Then the purpose of prototyping. The main purpose is to reduce risk by identifying problems early. Users can see how their requirements are being implemented, and developers can verify that the design works in practice. To construct the prototype, we again use the some concepts of a data model. Constructs such as elements with their data types, groups of elements like entities, records, or tables, and the relationships among those groups. These form the skeleton of the working model. In short, prototyping bridges the gap between requirements collection and the final system, ensuring the database application is practical, user-friendly, and meets organizational needs. The final step we will discuss is testing. Testing is the process of executing application programs with the specific intent of finding errors. The purpose is not to prove that the system is perfect, but rather to uncover problems before the system goes live. Effective testing requires carefully planned test strategies and the use of realistic data that simulates actual working conditions. For this purpose, we develop test cases at the times of analysis and design. For example, using real student records or transaction data helps identify practical issues that may not appear with dummy data. It's important to remember that testing can't prove the absence of faults. It can only show that faults are present when they appear. In other words, even after successful testing, we cannot guarantee the system is error-free, but we can build confidence in its reliability. Through testing, we demonstrate that the database and the application programs appear to be working according to the requirements gathered earlier in the development phase. So, in short, testing helps us to identify issues early, improve quality, and ensure the database system performs as expected in the real world. Let's conclude our discussion. Database planning and design is the foundation of successful database system. We studied the database development life cycle, covering system definition, requirements analysis, database management system selection, prototyping, and testing. Each step ensures that the database meets user needs, remains secure, and performs efficiently. Proper planning reduces risks, saves time and cost, and ensures data integrity and reliability. In short, planning and design turn organizational requirements into a practical, secure, and efficient database solution. It's all for today. We will meet in the next video. Thank you. Allah Hafiz.